Okay. I guess these guys need to be coming where they are, because I don't know, I have to start. Anyway, the second module is module number 6 is talking about data modeling. Data modeling is, as we said, we could do it data flow diagram, which is independent of technology. And we have another type of modeling. It's called ER diagram. Now, an ER diagram basically is going to show you the relationship of entities. And entities are called files. In the old time, old schools, they call entities file. If you are a system analyst, that means you're working in the system development life cycle, planning and designing. That means you are really getting the requirement, the design, which is independent from the technology. So you do what we call it equivalent to the house, the blueprint. We call files entity. If you are doing implementation, programming, coding, we call that table. So let's agree, the old schools, they have a terms called file, like employee file, course file, customer file, which is in same terms called entity when you do modeling of independent technology, when you are practicing as a system analyst. When you are a programmer, mean you implement the system you need a database, and that database has the creation of that entity into table. So now let's understand how you can put all this into perspective. Well, think about, you have a screen, and this screen you want to computerize each one of us now here, okay, their name, nationality, qualification, and then we need to also to make sure what kind of skill these people have. Agree, guys? So if you have a group of friends, and if you look at that group of friends, you want to make a database. So one of the database you want to do, you want to say, you know what, I want to collect the name of the people, their nationality, qualification, and I want to collect what is the skill they are doing. Is that good enough for you, an example? Or you want me to give you another example? Another example could be is student registering for what? For a course. So which one you like? Huh? Registering a course. So let's understand the model of registering. When you register for a course, really what you are having, you're having something like this, a registration form. It have what we call the student name, student first name, middle name, last name, student nationality. Agree? It got also what? Student occupation. What we call it the demographics data. Then after that, the course that the student register, and in this case a student register a course, and in the course there is an assignment, or the course is taught by faculty. So we start always with something called a screen. So a screen here, we will say here is a data about the student. Here is a student is taking a course. And here is a course has an assignment. Happy guys? Clear? Now, in other words, we have an interface. And this interface, we need to model to create a database. So any system, you go point of sale system, now you go to any shop, any place, point of sale, you got here is the customer detail, here is the customer order, and quantity, unit, and here's the total price. This is a screen or not? It's a screen interface. We get this as a requirement. We translate this requirement into an ER model. And then when we convert this ER model requirement, we convert it into an ER model, entity relationship. After that, we go to each ER model and we say, okay, what is the field? Okay, why? Because we need to implement it using what? Database management system. So we take this ER model and then we go and select a database. Select database management system. What is database management system? It's like Oracle. It's like Microsoft Access. It's like MySQL. It's a programming. It's a program that allow me to create table. That means I will take an entities, customer, and I'm going to create a table, physical table in Microsoft Oracle, in Oracle or Microsoft Access, and I will call it what? Customer. I go and I create another one and I call it order. I call another one, I call it products. So mean that we take the ER model, we go physically create a database. Here we call that independent of the technology. Here we say it dependent of the technology. Mean I have to know which technology I'm going to use. Am I going to use Microsoft SQL? Am I going to use Microsoft Access? Am I going to use Oracle? Okay, guys? In this case, I am implementing what I plan. So you will use a database management system that will create a table, and then after that you have a table like think of it like you have an Excel sheet. It have the customer ID, customer name, first name, middle name, nationality, and so on. What do I need to do? I need to store data. Mean data has to be stored in. We need a language to store. We call that language data definition language. Mean a data definition language is allowing us to what? To define, create a table. Data manipulation language is allowing us to extract data. This one, the process is from building an application, requirement, identifying, to modeling, to building an application, to retrieve a data. Now, if I want to create an ER model for this, I know one thing, that a student, this student, usually how many courses he can take in the program? One or many? Many. So in this case, we say a student and courses. So we have an entity, a table, a file called student. And a student taking a course. So this file is having information about the student. Example, student name, student ID, student address, student gender. Everything we need to collect about the student. We call this an entity. We have another entity, is what's called courses. Courses. In this case, course. Now, we need an entity which is talk about course. We have two entities. Here, we said a student can take how many courses? One course or multiple courses? Multiple. So we call here one student can take many courses. We call this a relationship. We call this what? A relationship. In other words, between entity and an entity, we have a relationship. Mean we say what is the connection between an entity student and entity courses. In this case, the connection is that this student is taking many courses. Now we know that course is being taught by whom? By professors. So in this case, we have here is a faculty, and we have here is what? A courses. Now in this case, we say one faculty teaches many courses. Happy guys? So quick now. What we have done, we started with the requirement. And the requirement we have, it's coming from different people. It comes from the registration, it comes from the faculty, it's come the student, it's come the account. So in database design, in information system, we need to see and say who are the people is going to use the system. And what do they need when it comes to student. So somebody will tell you, I need to know the student status. Sponsor, not sponsor. I have also counseling. I have what? Counseling. Mean somebody who's a counseling need to have a piece of data. It says student, okay, social problems, okay, or student social support, or is this student a special need or not a special need? What is student disability? In other words, in the student entity, we need to put here student disability, or what type of student? Normal student, special need, handicap, and so on. We call this, it's an ER diagram. What's mean by ER? E is the entity. This is an E, entity. R is the relationship. Now, after we finish from this, we can convert it into what? Into program. So somebody open Oracle, somebody open Microsoft, okay, Access, and say create a table called student, has a student ID, number is 9, it's a number data type, and it's a primary key. We call that data definition language. Now, at the end of the course, I'm going to give you a name for software that you can download it for free. That software, if you do the ER model, you just do one click, it will write the program for you, where you can just create for you the program of creating this table in Oracle. So you don't need to type it. That means from the ER model, this software, once you do a good ER model, you say what are the primary key, what are the field, what are the type of data. Then you say create Oracle program to create a database. It will write for you the whole program, the whole syntax, which is usually is a skill people to learn, and your database is created. Once we have a database created, we are storing the data through what? Through a screen. And that's the reason, if you see, when you go and you are in your bank and you want to register a customer, you put his name, gender, last name, and you say save. What that save do? It goes to the database management system. It says, okay, now I have here is a customer name, customer address. So I need to put it where? In a table called customer. I have here is last payment loan. So I need to go put it here in a loan. That means somebody have created the ER model, and from the ER model, what they done? They created the physical database. Once you store the data, what you can do? Retrieve the data. So this is the summary of this module. So at the end of this module, you're going to understand the skill of how you develop an ER model, the skill of how you understand to identify the relationship. Which is, we call it one to many, many to many, okay, one to one. You're also going to understand what are the type of attribute, field, primary key, foreign key, multi-value, derivative field. So the way we're going to do it, I'm going to go through what? The PowerPoint slides. After we go through the PowerPoint slide, I'm going to go through case. We're going to do it together. We're going to apply what we learned. After that, we're going to do the material that you have in your book. Okay, guys? So that's a quick of what we are trying to achieve. Now, we have the term model. A model is basically a representation. Now, data modeling is a technique for organizing and documenting the system. We done data flow diagram model, which is basically showing me the processes, external, the flow of the direction of the data, and the storage. But the ER model is not showing me the processes. It's showing me the tables that I'm going to store it, which is the core for what? For designing a physical database. We call that data modeling, which is a technique where we say we have customer and we have order, entity and entity. This is a data and this is the data. Now we need to model this data in terms of relationship. So a data model is a technique for organizing and documenting system data. That means the worst scenario that I have all student name, student last name, first name, gender, course 1 description, course 2 description, course 3 course 3 description. All in what? In one file. This is exactly if you are putting it all in Excel file. What you're going to end up with? You're going to end up with limitation. That means you design your data in one file and you said, you know what? I am going to have only 3 courses for every student can take. What about if there is more in the future? So we call that kind of data is not normalized. An ER model is an entity relationship diagram. It's a data model utilizing several notations, data in spite of entity and relationship. We call it ER model because we have entity and we have relationship. That's the reason we call it ER model. Mean all my system, I will model it in terms of its entity, what is the relationship. Example, you have customer order. Well, if you look at customer order, what we have customer information, we have order information, and we have the products. In this case, the simplest way to do it, we say customer entity, customer order entity, and the product entity.
What about supplier and
Thank you. Now, that's right. If I want in my requirement, okay, I say I want to understand this product coming from which supplier. In this case, I know that this product could come from what? Different supplier. Agree or not? Like, for example, the water. You can buy it from different suppliers. Mean one product can be supplied by what? Different supplier. In this case, I need to do what? I need to have another entity called suppliers. In this case, I need to go to the requirement of what is my requirement. And based on that requirement, I will model. Now, another thing. I need to know also faculty nationality. Agree or not? Well, that means I have a field here called entity faculty, and there is an attribute, a field, called faculty nationality. Now I have 2 options. Either to put it in text, so somebody write KSA, somebody writes Saudi, somebody writes Saudi Arabia, somebody write the Kingdom of Saudi Arabia. In this case, if I want to get the counts of how many Saudis I have, each one of these will give me different counts, right or wrong? So what I do, I go and I do coding. I say example, 01, Saudi Arabia, 02, Bahrain, 03, India, 04, Pakistan. That means each nationality I have given what? A code. In this case, I will store here a nationality code. Then I need to have a master table, master entity. Here, I call it nationality. So in doing so, why I need to do that? Because I need to get performance faster, because the other one, even if I tell everybody, you know what, you write Saudi, 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 you know, in this case the system will go count how many words are equal, same spelling Saudi, but it's gonna be slow. When I'm doing it normalized, mean I do coding and then I have another entity for it, it will be faster. So now we call that ER model. What's this? This is an ER model for what?
Purchasing order.
For customer purchase order. That means I am having here an order. An order has a multiple items, okay, and this items is for a product, and this product coming from whom? Supplier. And this product has what? Stock. They could have maybe multiple stock. Mean in warehouse 1 I have 50. In warehouse 2 I have what? 100. In warehouse 3 I have 500. So I have multiple stock, and each these stocks belong to and located in where? In a warehouse. Okay, guys? So in other words, if you look at this example, you're gonna understand one thing. The example of this one is nothing more than what? Is like you go now to any shop and you say, you know, I'm going to do shopping, or I'm going to order a product. So you're going to have an order. An order has order details, item, and each items, it's belong to a product, okay, and that product is a product ID and a product description. And here is the product is brought by what? Supplier. And this product has multiple stock, and this is the stock, and this stock happened to be in a warehouse. So now I want you to take, you can take a paper from here, or you can work in a group in a minute. I want you to know one thing. What does it mean? What does it mean, this one? It's mean that somebody is like a paper. You know, when you go and you get the manual paper, somebody come here and he say, you know, this is an order. And somebody said, this is in this order, what are the items I have ordered for? And this is the quantity of the order. Unit price and total price. Happy, guys? And here is, this is a product, mean I have a product ID, product description. That mean order is this, product item is this, product description, which is coming from here, the supplier is here, and the stock and the warehouse. Do I have an entity information about the customer in this one?
No.
Suppose I want to add customer. What I need to do here?
New identity.
Where I do it?
Purchase order.
Here?
Yes, with the purchase order.
It will be here. The first. In other words, we say customer, place, order, order have an order item, an order item is for a product, and a product is coming from a supplier, and a product has a stock, and this stock is in a warehouse. So we call this entity is a customer. Now, what's the relationship between one entity and another entity? Well, a customer usually place how many order? Many. Example, we have order for August, order for October, order for September, December. Agree or not? It's exactly when you take your laundry. You are a customer, you bring multiple times. So the relationship is very simple. A customer has many order. And the order has what? One order has what? Many items. And these many items has what? One product description code.
Each item you mean?
Yes. Many items happen to be in the order. They have what? One
Unique item.
unique product code. And this item, okay, agree? Is what? Supplied by whom? By many suppliers. Now, a product, this product, we have multiple stocks. That's the reason if you go to BHS, they tell you we don't have this in our stock now here, but we have it in the other branch. We have it in the other warehouse. So, mean a product has what? Multiple stock. Multiple stock. The multiple stock, many stocks happen to be where? In one warehouse. So in this case, we have a relationship. Okay guys, clear? What is the relationship? We have different type of relationship. We have one relationship, we call it one to many. In other terms, one customer has what? Many order. So in here, if I put here customer, so I'll put for you here customer, and I'll put for you here order. So I'll say the relationship is that one customer has what? Many order. We use the symbol either M or we use like that. You got it guys? Clear? So one of the symbols we use, we call that cardinality. We call it what? Cardinality. Mean the relationship is this, many. Another relationship is one. Another word, a customer. How many gender has value?
2.
Cannot be two, male and female.
Okay, together.
Agree, no?
Yeah.
I have a customer, Muhammad Ali. There is a field. The field will be what? Male or female. So he will put for me 1. So in this case, the relationship between the customer and the gender is what? 1 to 1. In this case, we have it as a field in the entity, inside the entity. In the here as an attribute. We call that gender. We call this attributes, field. We have also a customer is defined by what? By ID. Thank you. So that is a field, an attribute. It's called customer underscore ID. Now, every table have to be what? Have to have a primary key. Like every door have to have what? master key. Why? Because you need to order the record. That means when I have a customer, and I have a customer named Muhammad Ali Abdullah, I can have too many Muhammad Ali Abdullah, right? So what I do, I give them another field and I call it customer ID. And that customer ID has to be what? Unique. So we call that primary key. And that's the reasons we put what? We put line. So the symbol of line mean what? That this field is a primary key. What's the concept of a primary key? Concept of a primary key, that it's a unique. It will not be allowed. We store the same number in the file. Now, so we call this is cardinality 1. Like for example, a customer have 1 date of birth. We have also many, which is example, student enroll in many courses. Agree or not? Employee has many skills. You have 1 skill, she have 2 skill, she have 5 skills. That's the reason we make it an entity by itself. After that, we have another one, it's called this one, the black dot. What does it mean? It means that can an order exist? Can a customer exist and he does not put an order?
Yes.
Yeah. Agree or not?
Yeah.
In other words, I can register, okay, as a customer, but I did not place an order. So in other words, we says here, look at that. One customer, that's the symbol 1, has many order. Okay guys? So now I put here customer. If you put in your book customer, put customer entity, put here a line. Here you will put what? A line like this one, mean 1 customer can have what? Many order. But at the same time, he can have 0 order. 0 to many. 0 to what? Many. So we have this, another one. We say 0 to many. So we call that 0 to many. In other words, this is 0 and this is many. Happy? Okay, now let's go to the second one. If you look at this one, 1 order can have what? Many item, but also can be no item. So here is 0. In other words, they did not place the order,
Okay.
the items. Here is purchase order. Many orders belong to what? 1 product. In other words, this is a product, 05 pen. You customer, in your order, you bought this product. I bought this product. You bought this product. Agree or not? Many order item belong to one product. In this case, we have here what? The attribute product ID, product description, product sales price, product unit price. Happy? Mean the entity has to reflect the information we want to capture about it. Now, again, one product, this product could be in the, we have it, but nobody has purchased it, right? Agree or not? So one product could be purchased by many order, or one product has what? Zero. Got it, guys? I know, easy. Now, let's go to the second one. Many products belong to many supplier. Exactly. These are products. You supply it, she supply it, I supply it. Agree or not? So we call that many to many. Now, can we have a product? Can we have a supplier and he does not bring us any product?
Yes.
Yes, zero. You got it? See that? Now, many stocks exist in what? One warehouse. Happy, everybody? So we covered the beginning of cardinality. We covered the beginning of entity. We covered the beginning of entity relationship. Now if I'm going to throw many things, you know what is a relationship. You know what is cardinality. Now, let's help each other in one more terms, please. Yeah.
How can a product be without any supplier? Like the product has to be
I can have some supplier register with me, but he has not brought any product.
Yep, and the vice versa.
Yeah, in business, it's like that. A supplier will come, say, you know what? I want to do business with you. So what we do, we add him in the master file. We give him a code. But he has not supplied us any product yet. So we call, zero there.
But
The other way around is that products, zero products, mean no products, has no supplier. That means possibly we have no products. It has no relation to a supplier. Okay, now.
Sir, product and product stock. This is what this is.
Product and product stock mean I have pen. Agree or not? You are buying from me a pen. Now I need to know what are the stocks I have. I could have only one stock. I could have multiple stock. Example. I have a stock in Manama. I have a stock in Khubar. I have a stock in UAE. So a product has what? Multiple stock.
should we have one after product?
Yeah, you should. Yeah, should. Yes. Now, let's go to this one. So I have another one. So we understand is this. What's this? One and only one. One and only one. Mean
One product, one.
you will have one employee in one department. Works in one department. One employee works in what? One department. In other words, I'm coming to a new trick for you to learn it. I have another one, it's called 1 and 0. I mean, you could have 1 and you could have nothing, 0. Another one is many and 1. That means I could have maximum, a lot of order, but minimum, 1 order. So where is the trick in reading this, understanding it? The trick is very simple. In every entity, I do two things here. I say, this is a relationship, entity, and this is an entity. I want to know the relationship between them. Customer and order. Agree, guys? Okay? I want to build this part of the relation. I want to know now which of these babies I need to plug in here. You got it, guys, now? I need to know which one of these plug in here. Okay? So there is a trick. You want to know what you want to put here. Well, many and 0. In other words, that's the one here. Think about it. We put two things here. One line and one line. Okay, we put here one line and one line. These are belong to here. We say, what is the minimum number of order? What is the minimum and what is the maximum? In other words, I will ask myself when I work here, customer, order. I'm now here. I will ask myself, what is the relationship between order and customer? In other words, what will be the minimum? What?
0.
It will be
Minimum 1.
one minimum is here. I must have one customer have at least what? How many? One order. So in other words, now look at it, guys. I want now, I'll do it here. I have here, again this is, here I have customer. Here I have order. And here I have products. So I need to do the relationship. I want to know now what will be my relationship between customer and order. Well, one customer can place what? Many order. Okay, guys? And the other one is one order belong to one order belong to one customer. Okay, so I have here, I say, what is the minimum number of order that a customer can place, and what is the maximum number that an order belongs to a customer. So it is 1 to 1. Now we go to the second one. What is the second one? Is this. Many order belong to one customer. Can a customer have 0 order? Yes. So in this case I have 1, 1. Okay. Now I need to.
This is not clear.
Okay. I have something here, read it this way. Minimum number, maximum number. Okay? One order, a customer can have how many order? Many. So that's many.
This is maximum.
So this is one has what? Many. Up to now, like that. Happy?
Yes.
One order belong to one customer. A customer can have 0 order. Okay? Now look at the second one. Order. Many order belong to what? Many products. Agree? Many order, your order belong to many products. A product, one product, we could have it here in the store, in the master, but nobody purchase it. So it be what? 0. Here is 1.
Because order needs to have at least one product.
An order should have at least one product. Happy, guys? Clear?
Very helpful.
Good. Now, if you know how to do it,
Yeah.
you almost are ready to have a master degree in computer science IT.
I want to do it next.
If you give even a system analyst, you tell him, okay, do this for me, he will have difficulties.
If I do this for what?
He will have difficulties. They will tell you 1 to 1, 1 to many, and like that. Okay, now you understand? So the question is that how we pick up from there. All right. Entity is what? An object. Car is an entity. Bicycle is an entity. Employee is an entity. So we explain different things in an entity. In artificial intelligence, in object programming, they use the term class, entity class, because we will not cover it here, because there is something called inheritance. Okay, we will not cover it. Now, entity are having Something describe them. Example, when you look at a car, entity car, how you describe a car? Model, manufacturing, what else? Brand, thank you. Car name, thank you. Well, we know that every entity have to have what? Have to have a primary key. Everything you have said, car, model, is called attribute. Okay, guys? So we call that attributes. If you want to describe a student, it is what? Entity name, student. What will be? Student ID, student age, student nationality, thank you, student email, student qualification. Agree? Very nice. Look at that. Student ID. We know that every entity has to be what? A primary key. Because we need to what? Record sequentially order the rows. Like an Excel sheet. Rows and column. So think of it like an Excel sheet. We need to have the data to be ordered. This is rows, which is, this is my name. This is your name. This is the other person. Agree or not? The data here, we call it instant data. Instant value. The columns, we call them attributes. Happy, guys? Clear? Now, in entity, it will be stored later on in the database like that. I need to have things to be searched quickly. So I need to have a primary key. So I need to select one of these fields to be a primary key. In this case, I will have what? A student ID. Mean nobody in this file have duplicate student ID. Then I have a name. A name, we call it a composite key. We call it what? Composite key. In other words, the name is an attribute, and that attribute is what? Can be broken down into multiple attributes. That's the reason they call it composite. Because the term composite means A, B, C, D. Mean it's group of things. When you say group of things, you give that a group of things a name. So that's the name you give here. So we call it student name or a name. What will be here, my friend? Thank you. First name, middle name, last name. Happy, guys? You're making my life easy. Okay, so we finish now entity. We finish now? Huh? Composite. We now going to add another type. It's called derivative. Called what? Derivative value. Mean, imagine I ask you what's your age in the student registration or the banking, and you tell me 10 years ago my age is 20. You come after 10 years, so in 2000 I store for you your age 20. So the application take this value 20, put it where? In the database 20. Garbage in, garbage out. That's what computer mean. Computer is the dumbest things. We human make it smarter by modeling, by analysis. That's what's making it. Okay. So when you come to me 2019 and I retrieve your age, what I will get? 20. Why? Because I store 20, I get 20. But I know that age is what? Changing. So that means I will here store not the age. That means anytime you come, the system will say, okay, today is 2019. Okay, I want to know his age. The first things I will ask what? What's your date of birth? Agree? So we call it what? Date of birth, which is what? Derivative field. Okay, guys? Derivative field mean you drive the field, you calculated the field value from another data value set. In other words, in age, I stored your date of birth. When I display it, I said system date today minus date of birth will tell me the age. If I want to know what is your GPA, what is your what? GPA. Okay? So I take basically GPA, I could calculate it.
Yeah.
I want to know, example, are you hypertension or not hypertension? Are you in a good mood or a bad mood? So I have an equation, A, B, C, D, that's it. So in other words, we call that derivative field. All right. So that is mean the value here will be driven. I give you an example. You want to calculate the total cost of the order. Agree or not? In your bill, let me show you something. I was looking in my file today. I thought to make things interesting for you. I've been teaching databases for the last 20 years. You know? So I grabbed one file for one of my students long time ago, because when we teach, we keep a file. So here is a file, a case I give to student. It's called Papa John's Pizza. That's how I tell them to model it. When we finish, I will ask you to do ER model for it. Look at this. This is basically has a total. It has what? Total. You remember we put customer order when I make the screen? Now we need to say the total, right? So the total is what? A derivative field, which is coming from what? Calculating. Changing. Yes. Mean I'm driving the values from another value. It's okay. Thank you. You guys are taking this? All right. Now, so the derivative field could be your date of birth. Derivative field could be what? Your test 1 plus test 2 total score. Agree or not? So in other words, in databases, we don't put test 1, test 2, test 3, and we put total. We say when we know test 1, we know test 2, we know final, we know total. So that's derivative. We want to see if are you pass or fail. So we ask ourselves, do we need to calculate it and store it as a physical data or no. So in other words, we call that derivative. Okay, what is the other field? Qualification. Qualification. What do you think of? Think about student qualification or employee qualification or customer qualification. How many qualifications do you think customer will have?
One can have many.
Thank you. In this case, that's another what? Field. But this field will be what? Will be what? Will be multiple field. That means we need to put another entity. We call it employee qualification. So we talk about entity attributes. What is value? Is the value you are putting it here. The score of my test. My name. And relationship. We talk about the relationship. And we talk about what? Cardinality. Okay. We need now to talk about, we talk about relationship, one-to-one, one-to-many. Okay, we said one, many to zero. We call that cardinality. So, objects have a natural identity like car, wedding. Okay, wedding is an event, right? So that means I will have entity called wedding. Purchase, order, example, invoice, okay, payment, it's an entity. Entity is basically, we model it. These are student is entity, places is entity, object is an entity, events is an entity, concept is entity. A person could be what? Customer. A person could be what? Employee. A person could be what? Student. Instructor. The attributes, we see what we need. Instructor means instructor. What is my business requirement? I need to know. Instructor name, instructor nationality, instructor academic profession, professors, associate professors, assistant professor. Okay, places, room, building. When we describe things, we describe it by its attribute. A building, we look at it, the size of the building, how many floor, how many story, car, how many tires, how many wheels, power horse, object, machine, okay, book. Example, books is an entity, number of pages, hardcover, soft cover, size. Events, example, flying, invoice, renewing a contract, reservation, wedding, workshop, and events. Concept, we create concept. Example, we create concept of qualification. It's a concept. We create concept of, example, wealth. Okay? I want to have entity about wealth. Okay. Economic situation of a country. We create it as a concept.
Sir, what is not an entity?
What is not an entity? Nobody asked me this, but I'll tell you. Anything you don't want to store in your database. Anything you don't want to store. For example, with customer order, what else the things you don't want to store? Anything you want to store has to belong to entity. Okay? If you look at customer order, we have customer, we have order detail, supplier. Okay? That means you define entity as based your requirement. Anything not your requirement, so it's not an entity. That's the only way I can answer you. So entity means something we need, field that we have, we need to store. Okay, so later we'll do an example of normalization. You know, we'll make, you usually have an Excel sheet. You know this person now. You will make a row of Excel sheet. The name of the person, contact, date of birth, where I met him, his scale, how many cars he have, how many friends. Okay? You put it all in one row. You want to turn it later on in what? In a database. So you need to break it down into what? Entities. Entities, you need to say which are the fields you need to store them. Yeah. Now, we have something called strong entity. I'm getting a little deeper. And we have something called weak entity. Strong entity and weak entity. Example. This is your employee, and your company wants to know how many children you have. Agree or not? So, employee is a strong entity. Why? Because it must exist. We must have employee name, employee address. But some of us, we don't have dependents. So we call that entity what? Weak entity. Okay? So what is a strong entity? A strong entity can exist independently. Example. Supplier is a strong entity or not? It can exist. Nationality, it can exist. That means in my system I have an entity called nationality, and I have one of the nationality code here, instant value. It says Brazil, but I don't have nobody work with me from Brazil. So the entity nationality can exist without any dependent. We call that strong entity. It can exist without a child. Example. Employee have dependent. This is parent and this is a child. Employee have a project. This is parent, this is a child. So weak entity dependent on the existing of the other entity. In other words, can I have a product without a supplier? No. This is a strong and this is weak. You understand, guys?
Yeah, minimum there has to be one.
Yes. So now we call this, okay, a strong entity is an entity can exist without what? Depending on another. Example, customer can exist without depending on what? Order. But order cannot exist without customer.
And same if we take the relationship
Yes.
for order and product.
Thank you. So in other words, I need to understand when I have entities, which one is strong and which one weak. So that's it. Now, the owner is the entity which is what? Identify the owner is the entity on which the weak entity depend on. In other words, who's the owner between this and this? Thank you, supplier. Agree or not? Who's the owner between customer and the product? Customer. Who's the owner between nationality table? 0 Bahraini, 2 Saudi, 3 Indian, 4 Pakistani. You understand? And we have another table called what? Employee nationality, right? In this table we put for only the code. Here we put what? Employee nationality code. So, which one is owner nationality table? Right? Because the code, owner nationality code here cannot exist without that. We call that parent-child relationship. So what I have done, I opened the ground with the overall difficult scenario, then I start to explain the concept and plug it. You got it, guys?
Yeah.
Now we are explaining more detail, which you will understand it more. So we know what is a strong entity, we know what is a weak entity, we know the owners, identifying the owner. Okay. Now, part and supplier. Okay? Represent by the entity name in the clause in a rectangular. This is an entity and this is what? A relationship. In other words, we say this is an entity supplier and this is entity part. The relationship supplies. That means supplier supply parts. One supplier supply many parts. Many parts supplied by many suppliers. Now, both entity below can independently exist. Okay? In other words, I can have a table here, say parts, and I have a table says what? Supplier. They are independent. This is weak entity. Weak entity will also have a weak relationship. Example, employee and dependent. Can anybody in the street see me and say, "Hi, Daddy"? No. I must be married. Okay? To have a children. Yeah, exactly. I agree with you. That's the reason I am not sitting in. When I was a student, I never sit on Father Day in my house. All right, now, so we call this employee is an owner, and this is what? Dependent. We represent this by what? By the double border. We call this basically owner entity because it is what? It must exist. We can have employee exists information without depending on that. We have this called suppliers is an entity. What we have here? Dog. Now, this dog, date of birth. You remember date of birth? In this case, we have an entity, members, belong to a particular class, and that is basically is a derivative what? Field. So we have, if we have an entity, that entity we call it veteran for a veteran system, which is hospital treating animals. One of the entities will be what? Patient. So in this case, it's this entity is different than a patient in a hospital human. Because this is for an animal. An animal belongs to an owner. So I must put a field called owner ID. You understand how we develop entities, attributes? We look at the business. What we are treating animals. These animals has an ID number. That's it. This animal has a type, breed, sex, date of birth, and name. And this animal belongs to who? To an owner. So each one of these we call them what? Attributes. All this, my friend, called what? Entity. This entity, how many attributes has? 3. What is the primary key? Student ID. How many instant has? 1, 2, 3, 4, 5, 6. Okay? Rows, record, instant value. These are instant value. You got it? The cells. What is foreign key? Can we do this together? Look at that. A foreign key is employee and nationality ID. Happy, guys? Clear? In other words, if I put here nationality description, is this right or wrong? Just student, first name, last name, first name, nationality ID 01010203, and here is what? Description. Agree? What's happening in this place? I am repeating the description, nationality description many times, right? So this is not normalized. Why? Because one of the reasons for modeling database is to eliminate duplication. Now I have here, okay, maybe 5 out of these 6 Bahraini, 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 Bahraini. Agree or not? So what I need to do, I need to normalize it. To normalize it, I only put nationality ID. Happy? In other words, in another entity, I have called nationality entity. I have nationality ID as a what? And I have nationality description. And maybe I have here another field, status of the nationality, another field, language, primary language. You understand, guys? In other words, look at this. Now I am teaching you primary and foreign. Okay, guys? Primary is this. Number 1, this is the table. What I have? Student ID, name, nationality ID 02, 03, 02, 01. Happy, guys? Now here, what I have? How many? Let's assume only we do this and this. 3. We have nationality, to make it so you understand it, nationality ID, description, and status. Okay, guys? So nationality ID is 01, 02, 03. You got it? Okay, guys? Now assume I have 10 million here, people. And they are all the 10 million, either Bahraini, Saudi, Pakistani. Okay, guys? So I have 10 million people in the street. Here in this table, I'll have how many? 3. Okay? Now, we call this field foreign key. We call it what? Foreign key. We call this primary key. Clear? Mean that for this entity, this is the primary key. You got it? Where is the primary key for this entity? Student ID. Primary key. Happy? Now, think of it as a pipeline. We need to make a connection. Mean, there must be a relationship. Agree or not? Clear now? What is the relationship? This is the relationship. The pipeline. You know, like you're putting a pipe. The pipeline is very simple. It says that this has to be what? With this. So, we call this relationship. You understand, guys? In other words, this is a primary key and this is foreign key. This is the relationship between this table. So, we have a primary key and a foreign key. A foreign key is the primary of one entity. It's a primary of what? Of one entity. Which one? The nationality entity. That is contribute to duplicates another entity for instant. That is where? This one. If you look at this, we have duplicate or not duplicate? Duplicate. So foreign key allow for what? Duplication. Why we need foreign key? Because we want to eliminate the description in here. Okay, guys? Now, foreign key always match primary key. What does it mean? The name here, example, na underscore ID is exactly the name here, na underscore ID. If you call it nationality ID, is exactly like nationality. So they are the same name. Foreign key may or may not be unique. Why may not be unique? Because we need to allow for duplication. The entity with the foreign key is called what? Child. Where is the parent? Agree? Where is the child? Agree? Example. You are a parent number 01. In this club, how many child you have? 1. You are a parent 02. In this club, how many children you have? 2 children. You are a parent 02. In this school, how many you have? 2 children. You understand? So, a foreign key is a child. Mean this is a child and this is parent. This is a child, this is parent. Entity matching. Primary key is called what? Primary. So this is a primary key, primary parent. This is a parent entity, and this is a child. Okay, now parts, supplier, and product. Product and order item. In the order item, I have a product, right? Item. The item Where is the parent key for it? Is an item entity. Why? Because it has the item, it has the description. That means I cannot go add a child without a parent. In other words, imagine you have a screen here, customer, and here is a field called customer nationality, and you put 8. What's going to happen? It's going to go check. Is 8 exists here? It doesn't exist. So what will tell you? Invalid value. We call this data integrity. Mean that you cannot add a child without a parent. Happy guys? Clear? Look at this. We have what? Primary key. We have what? Primary key. We have foreign key. Let me explain this model for you. This model is a model of what? Student, and student live in a dorm. They live where? In a dorm. Mean in a hostel. Mean in a student house. So we have here is student name, last name, first name, and the dorm where he lives. How many dorms we have in the university? 2 dorms. Smith and Johnson. In other words, how many students live in dorm Smith? 3. So this is a primary key for a parent, and this is the foreign key, and this is the child entity. Okay guys? What's this? You should know how to answer this. Okay. Let's take it together. We mention it here. How many entity I have? 1. That's right. And this entity, how many major attributes there? 1, 2, 3, 4. Where is the primary key? Yes. How you know it? Because it's underlined. MashaAllah. Doing very good. Very good. All right. Which field is a composite?
Student name and address.
That's right. Address is a composite, student name. Which one is? What we call this?
Dependent weak.
We call it multi-value, weak. We call it what? Multi-value. Why we call it multi-value? Because a student can have multiple qualification. Agree or not? When you go for training, you get your certificate, right? We can have here also certificate, training. So the words design, we say, you know what? We will put certificate 1, certificate 2, 3. But you brought for me 4. Example, I have 4 certificates. You will tell me, no, sorry, you select one of the 3. Why I select one of the 3? I work very hard. Okay. You tell me training, you do more training than me. So we call it what? Multi-value. Mean that we can separate entity. We call it 0, student ID, another entity here, student ID and qualification. Alright guys? Attributes can be applied to relationship of entity, can be name, existence on dependence, simple composite. What's this? Attribute. It's an attribute, right? Agree or not?
Yes.
This could be anything, descriptions, anything. We put a description, for example, nationality description. Example, your address. This is what?
Attribute with a...
It's a primary key. This is what? How many of you is married? Okay, when you have the gold in your house and worth like 1 million.
Yeah, I'm the one who's married, sir. Because only I'm the one who's married.
No, I am also. Okay. The other question you need to ask, how many are happily married? Okay, no. Now, look at it this way. When you are in the bank, there is safety deposit or not? Safety deposit. The safety deposit, you have a key and the bank have a key, right? Agree or not? So it is 2 key. We call that composite key. Mean, if we say flight number, flight ID, you have now, you go to the airport and you know that you are going to fly on Gulf Air 071. This flight is a daily flight flying from Bahrain to London by Gulf Air, right or not? So you see, she flew on this 2 weeks ago, flies GF071. You flew a month ago, GF01. So what distinguishes you from them?
Date.
The date. Otherwise, if she keep flying, she will be only, we store for her as a primary key only one time. Agree or not? So in other words, in entity, sometime we need to have this field plus this field. This field plus this field. Example, flight number and date. So you fly GF71 11/2019. Tomorrow you fly another time 11/2013. 11. We call that what? Composite key. An example is order number and product ID number. Mean that you are ordering the same product, different time of order. In this case, if you look at it, we call that composite key, where flight number is a combination of A plus B. Flight number and date number. We call that what? Composite. A primary key can be one field or can be what? What? More than one field joined together. They call it sometimes joint key. So example, I could have drug and patient. Okay? But I need to know when this patient took the drug. So I need a date. So patient, drug ID, and date. You understand? Now, this is, we call it composite. What's this? This is a boat, right? We are now going to make a system entity. We want to collect data about boat. So that means we have an entity called boat. The primary key is what? Boat number, model, make, owner, name, port of resident, which port it is, and Christian date mean the date of manufacturing the boat. So if I want to know the age, I will know it from here. Agree or not? If I want to know how many boat an owner, each owner have, what do I need to do here? Huh? If I want, you are an owner, you have a boat, okay, he has 5 boats, he has 10 boats, you are here. I want to know how many boats each one of us has. Huh? Owner ID here, agree or not? Agree? So I will only put owner code, owner ID, and I have another entity here called what? Owner entity. Yeah, which has what? Owner ID, owner name, mobile. Same things what we done with nationality. So, you understand, guys? In other words, database is the easiest things to design. So what I done, in database we need to have counts. Easy. So the easiest things is to have count by numbers or by code. So what I do, I put code, owner code here, and I create another entity. I call it owner entity. That one has what? Owner ID, owner description, owner address. It's similar to this concept. Instead of nationality, what I put? Owner. Both owner. Owner ID. Owner description. Owner mobile. What's this? We discussed this. We have simple and we have composite, right? So this is a composite. Address, first name, middle name, last name. So we call this composite. Now, this one, single value. Why single value? Because in the date of birth, I'll have only one value. Agree or not? If I have one mobile only, I will have what? An entity here says what? Mobile. Nationality ID will be single value or multiple value?
Can be multiple. Your nationality.
Yeah. Huh? Thank you. If, I agree with you. If the rules of the country is you have only one nationality, that's reasons in Bahrain by law, you cannot declare you have multiple nationality in the public. By law. Because it does not allow you. Okay? So that means in the system, one by the requirement is to have what? One value. So we call it single value. Example, I'll give you an example. I cannot, the rules of your bank, that you have only one title. You have what? Only what? One title, one job title. So that is what? Single value. What's this?
Multi-value.
Multi-value. Like what? Degrees. Like skill. Like languages. Like courses you have taken. Like sport you do. Mobile's number. Mean that a person for this attribute has multiple value. So we represent it by what? So what's this? Tell me now.
This is primary key and this is secondary.
This is a primary key, and this is what? Multi-value. Now, to normalize it, I will go put here another table, eliminate that, another table, I call it player ID and membership, and agree or not? So here I have we translate that into another entity. We call it player ID 01 and membership ID 01. I have another entity called what? Member entity, which is 01 and description. We discussed this, we call it what? Derived value. Derivative derived value is the one that can be calculated from the store. You derive it. Derivative. I like this one. Time dependent data. What does it mean? In banking, what is the time dependent data? In banks, what mean time dependent data?
Depreciation.
Data that change according to time, seasons, price of airlines. You can fly Bahrain, London 600 and you can fly 200. Agree or not? So we call time dependent data. Some attribute will change over time. Example, your inventory. Okay? Based on the price of the product, based on what? The season. Tomato, watermelon, mango, depend on season. Video, based on season, based on time. Hotel, based on time. I mean, I have in my design, I say the room price of this hotel is changing with time. Now I need to classify time.
Weekend, weekdays.
Thank you. You got it? So we call this kind of data is what? Time dependent data. Example, the rate of interest fluctuate, right? Example, the stock prices, okay, changing with time. 8 o'clock, 10 o'clock, 9 o'clock. Whenever Trump talk, then prices goes up. Cut this one. You have always cut, huh? Otherwise he will be upset.
He loves Trump?
No, he's my friend, no problem. Now we know this relation, enrollment, student, right? We call that what? This is usually represented as a verb. And this is represented as a what? Noun. So please, this is noun, the entity is noun, and the relationship is a verb.
This time dependent data.
Huh?
This time dependent data, how should this be handled?
I'll tell you.
Said something.
Yeah. How we handle it, we put in entity the hotel rate, and we say, okay, we want to have, like this lady said, we want to have it, look at that, we want to have it days, Saturday, Monday, this, but also it differ in summer than winter, right? See how I handle it? So as a system analyst, this is where the intelligent programmer just do like this. Analysts think. Say, you know what? I know the rate of a hotel is changing. So it's changing. So what does mean changing? First of all, How does it change? Well, the business owner, the manager of the expert, business owner, leave the expert nowadays, but will tell you the change will be based on day and based on season. Happy, guys? So what I do in that entity, I put there price. Agree or not? Agree? Now, the price will be day, room type, and season. So I have season 1, season 2, season 3, 4. Okay, guys? One way this is to do it, that I classify it. Another one come, you say, no, I'll tell you the prices will be based on, that's not too complicated to do, will be based on your occupancy, based on supply and demand. So in other words, you go check the rate. Every day you check how many people you have in the hotel, how many the occupancy rate. So I can afford to give you, I have only 10% occupancy. So we'll say if occupancy between 10 and 50, then you give 50% of the price. If it's 50, 70, 20% discount. If this. You understand, guys? So that's how you do it, all right? We call this student ID name. That's an entity, right? We call this entity courses. Primary key course code, course name. The relationship between them is what? Grade. Student enroll. When a student enroll, what is the attribute I need to store? Grade. So that is the attribute, I'll put it in the relationship. Grade. Now, attributes and relationship. However, when you normalize it, you will not do that. You will create another entity, okay, where you put what? Student enroll courses. All right, guys? That's another entity. They call it bridge entity. They call it what? A bridge entity. Mean, this is a student and these are the courses. Like in your program, for example, 10 courses, right? But now I need to know each grade, the grade of the student in these courses, 3 courses he has taken. So I will create another entity here. I call it student ID, course ID, and grade. The third entity will be called what? Bridge entity. But here I need to show in my model that there is in this relationship, which is enrolled, I'm expecting to have a field that has what? The grade that the student got for the course. What we call that? Honorary, right? Which is what? Honorary relationship between instance of a single entity. Date of birth, one nationality, one title, one major. Okay, guys, clear? That means it's only one instant. Usually this is why it's written like this, is going back, because it will be stored in the same entity. You understand? This is called what? Binary entity, which is what? Relationship of 2 entities, 1 to many. One student enroll in many courses. I already spoke about this, right? Cardinality. One-to-one, one person has exactly one text file. Okay? One person have one text file. For example, every business in Bahrain, they have one VAT number. Okay. One to many, one person can can place what? Many order. Many too many mean many students enroll in many subject. Many subject has many student. So what we do here, we do a bridge entity. So we call that in ER, when we implement ER, many to many, we solve it by what? By a bridge entity. Cardinality, we discuss minimum of 0, here 1, many, all of that. What you have here? What do you see here? Maximum number of instance that is given in entity may be associated with what? Single related. Can be 0 or many. So many, parts supplied by what? One supplier. That's right. 0 part, what? One supplier. 1, again, one supplier give us what? Many parts. What's this? We discussed this, if you remember. We done it together. Okay? Again, if you see is the cardinality. Now, business rule. In other words, when you enter CPR number, what is the business rule? It has to be what? 9 digits. So we, in an attribute, we have business rule. So let's read. A statement that defines or constrains some aspect of the business. It intends to assert the business structure and control. Means somebody has told us, when you enter a CPR, it has to be what? 9 digit. Somebody has told us, you cannot leave first name blank. Somebody told us that the quantity cannot be left 0. You understand? We call that what? Business rules. So we have in database something called, in a minute we will do that, called data dictionary. Mean in other words, how we defined student ID. So we have something called field name, which is attribute name, either one. We have data type, what's mean data type? Number, character, image. You understand, guys? Okay. In other words, when you put your name, when you put gender, what is required? You put character, no? M or F. That's it. When you put student score, what is data type? Number. When you put CPR, what is data type? Number. When you put video, what is data type? It's called media, blog, image. Then we have data length. What is the data length? Mean the length of the field. Example, you have customer ID. They will tell you what is the length of the customer ID. You say it should be what? 9. Okay, then constraint. In other words, what is the business rule? Condition. It should not be null. That means it should not be empty. Okay? It should not be date of birth, for example. Date of birth. What is date of birth? Date of birth, if you put, thank you, if you put date of birth, future date, it should not allow you, right or wrong? Okay. Yeah, or format. Or, for example, you cannot say to me, example, if you say, I am it's a condition. Example, if you tell me how many hours you work in a week, and you put for me 5,000 hours, can be done? No. So what will be range? So we call that constraint. So each one of these is a table. Example, student ID, date of birth, address. Date of birth will be what? Data type? Date. Length will be the number of the value. Constraint will be less than today's date. I will give you a break. I'm finishing almost. We have something called database, conceptual design. We talk about relationship. We talk about normalization. We have first level normalization, second level. After you come from the break, I will talk about this one. Okay, guys? I will teach you normalization in a very easy way to understand. Normalization means how I will break redundancy, create relationship, create foreign key. We have 3 types of normalization. Enjoy. Anybody lost? If you remember, we spent good time on before the break on the AR model, and we gone through it. Now, we want to put it all together by learning the concept of how you really go through these steps to develop a database application. So this is called database approach to database management system. So in other words, if you remember in the beginning, I said you get the requirement, you do a user interface that is from different party. Then upon that, you do the ER model. Then from there, you map that ER models, you do the attributes, and later, what you do, you select the technology and you implement your database. We call that database designing. So designing a database requires 2 major aspects. The first is called conceptual design, and that is the ER model, conceptual design, which is an abstract of what we're trying to achieve. So we do the entity, the relationship, the attributes. And then after that, the physical design, which is we select the technology we want, the database, whether it's an Oracle, whether it is in Access, Microsoft SQL, and then we implement the database. We need also to understand how we do what we call database process by identifying the relationship between these entities. And it's most important, we need also to know the data elements, what we lead to each table or entity, what are the attributes, what is the type of data, what is the data length, and what is the data constraint. So we call that data dictionary, mean descriptions of the data. And in this case, we want to know what is the descriptions for first name attribute. So it should be the first name, a character. It should be not more than 25 length. It should be that's the data type is a character, the length is 25, and the constraint null is not allowed, mean that the user need to what? To enter it. When it comes to value, like example, binary value, male, female, so we check for what? Integrity of the data. We say check for value M or F. So in this case, we have another terms that we practice it through what we done. If you remember, we said you have the nationality here, ID, and if you put nationality description, will be what? Duplication of data. This process is called normalization. The concept of normalization is streaming the complexity in terms of data redundancy, terms of foreign key, multiple value, in order to eliminate data redundancy and working out the relationship. We have three types of steps for normalization. First level normalization, second level of normalization, third level of normalization. First level of normalization is entity whose attribute has more than one value. The single instant may be broken down into a separate entity. So if you look at it, you have what? You have, skill 1, skill 2, skill 3. So what we done? We break it down. You have an all customer item, item order number, item 1 description, item 2 description. So we break it down into entity. Second, and that any attribute that have multiple value actually described in a separate entity. Example, here you have nationality and description. The second normalization is we identify the foreign key and the primary key, which is we have done. So that means you look for the keys and you say this is the primary key, this is the foreign key, and you try to what? To ensure that the relationship of the data integrity is good. The third one is that non-primary key attributes, for example, dependence on the attributes you look for, whether there is a relationship between the data. Is it one to many, one to more? So now try to work out this one. Work it out as a group. This is a data, I will tell you now. Okay, this is a data, is basically assume that it is all kept on your Excel. So it is on your desktop, in your Excel. So imagine that we have here 10,000 rows, mean record. This is the order number. This is the order date, part number, part name, unit price, quantity. This is supplier of the part, supplier name, supplier street, supplier city, supplier state, zip code. Now, what do you see of this? Well, one of the things you see, this is not normalized. The second thing you see, that is there is a lot of data redundancy. So to do that, this is called a record we have is not normalized. So how we go on normalizing it? We break out these entity, these fields into a group of entity. So let's see that. We start with something called the strong entity, the master value. We have, here is information about the supplier. We have an entity, one called supplier, and in this case, this is supplier number, and it's the primary key. This is the supplier name, supplier street, city, and zip code. Now, this is another one, is the part. Okay, that is the part entity. We have the part number, part name, unit price, and supplier number. Now remember this supplier number exactly as it's written. It has to be exist here, spelling, and exactly as it is written exists in the master table. So we call this is a foreign key, and we call this one what? A primary key. We call this is a parent, and we call this is a child. And the relationship is that one to many. You got it, guys? In other words, I have eliminated the redundancy. The second things we do is the item. The item is this item, okay, part number, which is coming from here, and the part quantity, which is the purchase order quantity, and in this case, this is belong to an order number. So that means I have the part, you need a quantity for a given part, that one belong to an order. So we call this line item or order details. In this case, we have, this is a joint key or a composite key, because an order 101 has part 1, an order 101 has part 2, an order 105 has part 1, and order 105 has part 2. So that means we are allowing for every order one part record will be there. Now we have another one here, is called the order, okay, header, and that is order number, order date. Now I can add here branch, I could add order salesperson, whatever I want. So now if I want to create a relationship, okay guys, what I will say, order has many item, so this is order has diamond many item, and item is, which is a part that goes to the part entity, and a part coming from where? From a supplier. Okay? You want me to do it for you? So if I want to convert this into an ER model, it will be a very straightforward. It will be order, okay, it will be item, okay, line item, it will be parts, and will be supplier. In other words, one order has many items. An item belongs to parts. Okay, many items belong to a part. A part is basically to a supplier. You got it? So in this case, we done the normalization. In other words, we breaking down all this non-normalized record, which has a lot of what we say is redundancy, not normalized. We don't know the foreign key, the primary key. We don't know the integrity of the data. Now we go to a database management system. After we do the modeling, we go on implementing. A database is nothing more than a collection of tables. We use a database, it has a catalogs, that means it has a metadata, data dictionary. We are starting with the data conceptual framework, conceptual design. We basically, which has an entity, attribute, relationship, we translate them into a physical program. To do that, we need a database management system. Oracle is a database management system. It's a software that allows us to create a table, maintain, grant control, insert data, and access. A good example of databases, you find them all over. In a supermarket, banking, library, university, everything. It's a collection of data. In a typical database, you got what? You have a program, that's an application. It could be customer order, student registration, it could be employee record, it could be payroll, an application. This application, we need to do a queries, we need to do a search on report, data mining, anything like that. We have a database, DBA, called Database Administrator, who is responsible for the design and administering the data. We have here within the database many functionality. Functionality allow us to create a table, we call it DDL. Functionality allow us to search for data based on criteria and retrieve, we call it DML. It allow us to develop an application, a form, a screen, a report that is called program object. It allows us to do database managers, which we do control who is going to have access, who's not. We have something called data dictionary, this is the data dictionary. It's describing the attribute, the business rule, where is the data stored, how it is stored. We have a file managers, which is really managing where is the data, each table, where it is physically stored in which hard drive. And we have buffer and access method for optimization. And all our entity and tables are stored in a database. We have also in the database file like what we call it user logon file. We have other special files. We have two types of language, as you see here. DML, DDL. The first language is we want to create the table called customer. So we call it data definition language, which is a language that allows you to create this entity in a program. Data manipulation language is allowing us to what? Generate a query, search, retrieve data. Logical design, we've been spending on it, which is the schema, sub-schema, the model. The physical design is the implementation of the database, is the programming. Example of data retrieval, we use a command. Example, if we want to retrieve, select for me all employee ID, first name, last name, nationality, then I need to select a statement called select. But if I want to select, I have to say from where? I say select from the table. I know these fields all exist in a table called customer or employee, so I say from employee. So if I want to insert, I say insert, means store. If I want to update, I say update data, mean modify, alter. Delete this, and merge. So here is, since it is data manipulation, we are updating a data, we are changing a data, deleting a data, and we are merging from two places. We have another one if we want to create a customer table, employee table, course table, like what we are doing here. We say create. I want to change the structure of the table. Change it from, example, last name, 25 character, I want to do it to 15 character. So I'm changing the design of the table. Drop, I am dropping the table, like I'm deleting it. Rename, I am changing the customer table from customer to, for example, customer old file. I'm changing from EMP to employee, the name of the file, the table. Commit, as you are working, you want to say that I want you to commit to save the data. Grant, revoke, mean you are granting somebody an access. That's reasons when you are working in database, you must have a password and log on. So somebody have to grant you that and grant you the privilege. That's a grant. Revoke. Once you know Oracle databases or MySQL, you will be certified, your salary will be very high, and you will be very widely wanted in the market. If you know database analysis and conceptual, that's something needed. So example, you could say select from a customer so and so. It's an international standard, mean that Oracle is using it, MySQL using it, Access is using it. These are standard language for a database. This is an example. Select last name, salary, name, salary. So I'm selecting from employee table the field last name and the salary. So it will list for me everything. If I eliminate this and I put the semicolon here, if I have 100,000 record, it will select all. But here I said where salary is less than or equal 3,000. Here it will list for me these two people. Here I say select for me job ID, salary, some salary, payroll. Okay, that means I want to say, the total salary for programmers in my organization I am paying today is 19,200. So it will go mean every employee I have for them a job ID. And here it went and brought for me, I have 3 employees. There are 3 type of job in my database. IT programmer, AD press, AD VP. These are the total salary for everybody. In this case, I say select. The field is job ID, which is IT, press, all that. Sum is an equation, summing their salaries. If they have 5 people IT, that's the total salary. And you turn this into a label for the report, call it payroll. So that is mean how I want this label of my sum will be. From employee table, where ID not like so-and-so rep. So that means I am eliminating all these jobs, which is basically rep. Group by ID, having salary greater than 3,000 and so on. We have a data dictionary, mean we defining the data. So if you look at it, this is what I done data dictionary. I said every table, we need to know about every table, what are the field, what is the data length, data constraint. In Microsoft Access, this is Access, you have, this is the field called, example, in a table called supplier. In this tab supplier, if you look at it, supplier number is a unique. So if you look at it, it's a required. It's a long integer, and it is an index. The description here is called a data dictionary. So this is a data here describing this field. So a data dictionary is nothing more than a data describing a data. Example of an SQL statement is like that. I need to do a report. Microsoft SQL, it's once you understand a database, you could really generate, a database, and then you do a query and a report. So example here, I have a part and I have a supplier. Same thing as what we said. Here is part number, part name, price, and here is what? The supplier name. If you look at it, many supplier belong to what? One. So that is parents, and this is a child. This is a key, mean this is the primary key, and these are the fields. Now here you are coming and you saying what? Query for me, means select the data. I want the part number, the part name, the supplier, and the supplier number and name. Criteria between 137 to 150. So you're looking for a report within that. With one click, it will generate all the report for you, and you can download it in Excel and everything. We finish. Now, what we will do the exercise. So now, let's do with this one. Let's go to your book. Entity ER diagram, which is a graphic representation. Everybody's there? A graphic representation of an ER diagram. What is the strong entity name? Just give us a strong entity name. Now, what is the strong entity name? Could be. So, my advice, do number 6 and number 7. So I will go around and we will work it out.